This is John Samuel, Assistant Professor of Physics from Bishop Heber College, Trichy, India. My lecture is on hexagonal closely packed structure. Hexagon means six-gonal. The structure, this lattice is in this way. Here a layer is there. This has a center atom surrounded by 6 corner atoms. In the same manner, we have another layer. We have center atom surrounded by 6 corner atoms. Between these two, we have another layer. This is 3 atoms in between these 2 layers. So we have 3 layers, AB in this manner. So this is the hexagonal closely packed structure. Here we have the axial parameters. We have A equal to B, not equal to C. Means if we join all the centers, we will get a structure. So this side is called A. This side is called B. Means both the sides have equal lengths, and we have another layer. This is the height. Here we can draw, this is C by 2, and we can draw another height, this is called C. So A equal to B, both the sides have the same dimensions, but the third dimension is higher than A and B. And if we consider the interpolar angles, alpha means here alpha equal to alpha equal to 90 degree. Here we may draw another line. Here between these two is 90 degree. And if we draw another line here between A, B and this is 90 degree. And if we consider internal angle between A and B, total angle is 120 degree. These are all the axial parameters of HCP. So we have 6 atoms with the center atom. This is called base center atom. We have 2 layers. Between these two, body center 3 atoms are there. Now we shall study the unit cell parameters of this HCP. First parameter is total number of atoms. Even though we have so many atoms, we have to consider the corner atoms. Each corner atom is shared by 6 other unit cells. Suppose if we keep this here, so each corner atom can be surrounded by other unit cells. So each corner atom is shared by other 6 unit cells. So share of one corner atom means this atom is share of one corner atom is 1 by 6. So we have 12 corner atoms. So we have 12 corner atoms. From 12 corner atoms, the contribution of corner atom is just 2. And this base center atom is shared by another cell. So this base center atom shared by another cell means shared by 2 cells. So from these 2 base center atom, this atom and this atom, from these 2 base center atoms, we have 2 into half equal to 1. Besides that, we have another 3 atoms. These are all body center atoms. They are not shared by other cells. So body center atoms give this full share to this unit cell. So totally from 2 atoms from the corner atoms, 1 from the base center atom, 3 from the body center atom. So totally the contribution is, total number of atoms in the HCP is 6. Okay. And coordination number. Coordination number means number of atoms surrounded by another atom. So if we take this base center atom, here we have 6 atoms surrounded. Besides this, we have 3 atoms of this unit cell, and as well as we have another 3 atoms. So totally we may see, so this corner atom surrounded by this base center atom surrounded by 6 corner atoms, 3 base center atoms and 3 base center. Totally the number of atoms under this base center atom is 12. So coordination number is nothing but 12. Coordination number is 12 because 3 plus 6 plus 3. Totally we have 12 atoms. And atomic radius. Atomic radius. So we have all the sides. We have all the sides. If we keep the atoms here, we may compare that each side is formed by 2 of the atoms. So r plus r we have 2r. So r equal to a by 2. One side a equal to 2r. So r equal to a by 2. And before we have to find another parameter, that is packing factor. In order to find packing factor, we need to find C by A ratio, that is nothing but axial ratio. So this skeleton is explained here. This skeleton structure of HCP. The triangles formed by connecting the centers of all atoms with the center of the base center atom. So we have 6 triangles, 1, 2, 3, 4, 5, 6 triangles we have, and we have to draw one line for one triangle. This line is the height of the triangle. This line is the height of the triangle. This triangle is formed by the base center atoms. So if we join the center of base center atoms, we have a triangle. So from one body center atom, if we draw a line, the line joins here, that is point is O. This is the line. Here this is the point is C, this point is O, this point is P. P, C, O over here. This is P, this point is P, this point is C, this point is O. So we have to consider all these things, then we shall find the C by A ratio. Here I have drawn the triangle CAB. Here you can see CAB I have drawn here. I have drawn the triangle CAB. CAB, you can see here CAB. Here I have here CAB I have drawn here. So this is the CD. D is not mentioned here, but CD is the height of the triangle. So from triangle CAB we can find CD is the height. Height is given by root 3 A by 2. So and O is the point where line PO meets at CD. You can see here O is the point where this line meets here. Okay. So we have to find the value of CO, but we need the value of CD, but we need the value of CO. CO is nothing but 2/3 of CD. So if you calculate CO, we can get CO as A by root 3. So we have this triangle, we have all the values P, CO and PC, everything we have. Just I have mentioned I have put all the values. So you see here the point P is here, the point O is here, C is here. So C by 2, this is nothing but A, this length A, this height is C by 2, the height is C by 2, this is the CO length, this is CO length, A by root 3, A by root 3. So if you apply Pythagoras theorem, we may take that PO square equal to PC square plus CO square. Substitute all the values. A square is equal to C square by 4 plus A square by 3. So I bring all the A's one side and I take C square by A square. Finally I get the value C by A is equal to root 8 by root 3 is nothing but 1.633. This is the axial ratio which is crucial to calculate the packing factor. Now what is the packing factor value? Packing factor or packing density both have the same meaning. Packing factor is volume of atoms by volume of unit cell. Now we shall find the volume of unit cell. Volume of unit cell, usually in 3D structure we find volume by means of base area into height, cylindrical area. So we have to consider this is a hexagonal cylinder. So we have to find the base area, then we have to find the volume. So what is base area? Here we have 6 triangles, 1, 2, 3, 4, 5, 6, this is totally one triangle. So we have 6 triangles, so base area nothing but 6 into area of triangle. What's the area of triangle? Half into base length into height. We have half, base length is always A, height already we have known, the height, this is the height of the triangle we know, this is root 3 A by 2. by considering all this, by substituting all these things, we have found area of triangle as root 3 a square by 4. So base area is 6 into area of triangle. So we can find the volume of triangle, means this total is base area, C is the total height of that cylinder. So this is the volume of unit cell, and we got to find volume of atoms. Volume of atoms V equal to 6 atoms we have. So volume of one atom is 4 by 3 pi r cube, because atom in the shape of spherical shape. But we know R equal to A by 2, substitute these things, we get the volume of atoms. Then we can find the packing factor value. This is the volume of atoms, volume of unit cell. By on simplifying, we get 2 pi by 3 into root 3 into A by C. So from that we can substitute the value of A by C. We know C by A is root 8 by root 3. So if C by A means root 3 by root 8. Substitute the values, we have got the packing factor value as pi by 3 root 2. Is nothing but 0.74. 0.74 means 74%. 74% is the packing factor of HCP. That's why it is called hexagonal closely packed structure. 74%. So for examples of HCPs, magnesium, zinc, titanium, zirconium, beryllium and cadmium are some of the examples of HCP. Thank you.